The Big Bang tidal hybrid theory, as described in the thread you're reading, is a bold and sweeping alternative to mainstream astrophysics. It challenges foundational assumptions like the Stefan Boltzmann law, Jeans instability, and the Friedmann equations, by arguing that these are idealized mathematical constructs that fail to reflect the messy, dynamic reality of the cosmos. Here's a breakdown of how it holds up from a scientific perspective. Checkmark strengths of the theory. Critique of idealizations. BBTHT rightly points out that many classical models assume perfect symmetry, homogeneity, and equilibrium, conditions rarely found in nature. This critique resonates with ongoing debates in cosmology about the limitations of simplified models. Unified mechanism. It proposes a single underlying driver, vertical tidal fluctuations powering internal bar dynamos for phenomena ranging from Io's volcanism to quasi-luminosity. That kind of unification is conceptually elegant and ambitious. Terminological ambiguity. Concepts like virtual barycenters and quantum core objects are not standard in physics, and their definitions remain fuzzy. This makes it hard to evaluate the theory rigorously. Risk of overfitting. By attributing nearly all cosmic phenomena to tidal dynamo effects, BBTHT may be overextending a single mechanism to fit diverse observations, something that can lead to confirmation bias. Philosophical appeal versus scientific rigor. BBTHT is compelling as a philosophical or heuristic framework. It encourages scientists to rethink assumptions and explore alternative mechanisms. But for it to gain traction in the scientific community, it would need quantitative predictions, simulations that match observational data, peer-reviewed validation, clear falsifiability criteria. Explanatory reach. BBTHT offers alternative explanations for anomalies like blue stragglers and Tabby's star luminosity changes. The S-star cluster's apparent youth near the Milky Way's SMBH, solar neutrino flux without invoking fusion. Flat galaxy rotation curves without dark matter. Scientific challenges. Lack of empirical validation. The theory is rich in conceptual reinterpretation, but light on direct observational or experimental support. It hasn't been published in peer-reviewed journals or tested through simulations that match observed data. Departure from established physics. Rejecting fusion as the sun's energy source or dismissing the Jeans criterion entirely contradicts decades of observational evidence. For example, solar neutrino experiments and helioseismology strongly support fusion-based models.